Okay, so today we're going to cover section 6, and in section 6 we're going to prove angle pair relationships. So this will be the last section of chapter 2 that we cover. So the first thing that I wanted to bring to your attention is that there are different types of proofs. I believe I mentioned it yesterday. There is a flowchart proof also and a paragraph proof. However, the only type of proofs we'll be writing this year are going to be the 2-column proofs, where we have a column of statements and a column of reasons. But I want you to be aware of this just in case it appears, say, on a standardized test. So here is Theorem 2.3. Again, the number's not important to us, but what's important to us, we could give this one a name, and it's called the right angles congruence theorem. And basically all that it says is that all right angles are congruent. So you can either memorize the name for it or memorize what it says. It's almost the same number of words as restating what it is. If you want to abbreviate things when you write them as reasons and proofs, you could say right and then do the angle symbols, and then you could write the congruency symbol and write it like this. You could also write all right angles congruent, something to that effect, if you were writing this as a reason in a proof. So the next slide actually has an example of a flow chart or a flow proof. Again, you're not going to have to write flow chart proofs or flow proofs, but just be aware of what they look like. So they're like little boxes or rectangles, and then they have arrows showing the flow of the proof. We're actually on the next slide going to write a 2-column proof for this theorem. So we are going to basically take some of the same information that's on this slide, but now turn it into a 2-column proof. So let's go ahead and see if we can write our 2-column proof for proving the right angle congruence theorem. Now, once you're given a theorem, and just know that it's already been proven. So you won't have to prove a theorem within a proof. You can use the theorem, because it's already been proven, in your reason for a proof. So let's go ahead and fill in our reasons. They gave us all the statements. So for statement A, angle 1 and angle 2 are right angles. That was given to us. Then the next one, the next statement B, the measure of angle 1 equals 90 and the measure of angle 2 equals 90. This is going to be the definition of right angles, because we learned that a right angle has 90 degrees. Then the next one, we can either say that this is transitive or substitution. So like if you flip this around and put 90 equals the measure of angle 2, this is where you could see how the 90s cancel, and then that's how you get from measure of angle 1 equals measure of angle 2. So here you could either tell me that this is transitive or substitution. You don't have to put both, one or the other. And now going from the equal sign to the congruent symbol, this is just definition of congruent angles. So now, if you were given a question like this on the test, what you could say is you could do it in 2 steps, because we now have proven this theorem. So you could do it in 2 steps. The first step would be given, and then the second step would be what you're trying to prove, and your reason would be the right angles congruency theorem. So instead of having to do these 4 steps, you could go right and just say the theorem is your answer. So the next slide has Theorem 2.4. Again, the number isn't important to us. What's important is the name, and this is called the congruent supplement theorem. And what this states is if 2 angles are supplements to the same angle or to congruent angles, then they are congruent. So what they're telling us here, so if angles 1 and 2 are supplementary and 3 and 2 are supplementary, then that would tell me that 1 and 3 are congruent because they're both supplements to the same angle, which is 2. See how they both are supplements here to angle 2, so that's what's in common. So that makes these 2 equal. So they're both supplementary to angle 2. I'm going to prove this theorem. So it wants us to prove that angle 1 is congruent to angle 3, given that angle 1 and angle 2 are supplements and 3 and 2 are supplements. So they've already given us the statements. We just have to come up with the reasons. Now, notice on number 1, whenever I write a proof, I always try to put all of my given information in my first statement. I don't try to spread it out or give a separate number to each piece of given. So I wouldn't put that angle 1 and angle 2 are supplements as number 1, and then 3 and 2 are supplements as number 2. I just group whatever it is all in one statement. Next, we're going to translate or turn what supplementary angles mean and show that angle 1 plus angle 2 equal 180 degrees and 3 plus 2 equals 180, and this is definition of supplementary. Because I know when I add the 2 angles, if they're supplementary, they're going to equal 180 degrees. My next statement could either be substitution or transitive. Now, these aren't always interchangeable, so just be careful. Usually substitution works every time, but sometimes if they want a more specific, you would tell me transitive. So like I can see that for transitive, those 180s cancel out. They're both equal to the same thing. So that's why I can put 1 plus 2 is here, and then 3 plus 2 is here, because they both equal 180, so they're equally. Then the next one, I can do a subtraction property, sorry. I'm subtracting out the measure of angle 2 from both sides. So that's what step 4 is. So from 3 to 4, I subtracted. And you can put POE here if you want. If you just tell me subtraction, that's fine. And then now they're just going from an equal sign to a congruence. So that's just definition of congruent angles. Now, if you were given this and asked to prove this, you can actually, since we have this theorem now, you could do it in 2 steps. So step number 1 would be angle 1 and angle 2 are supplements. Angle 3 and angle 2 are supplements. That was given. And then you can go right to your proof statement that angle 1 is congruent to angle 3. And you would say the reason would be the congruent supplement theorem. So instead of having to do all this, because we now have this theorem, we can do it in 2 steps. So my next slide, again, the number is not important. The name is, it's called the congruent complements theorem. So just like with the congruent supplement theorem, this theorem states that if two angles are complements to the same angle or to congruent angles, then they are congruent. So just like before, both angle 1 and 3 are complementary to 2. So then, because they're complements to the same angle, we know that they're congruent. If you were to write a proof for this theorem, it would be the same thing, except for instead of making them equal to 180, you would set them equal to 90, because that's what complementary angles add up to be. So the next slide has a postulate that you'll memorize, and it's called the linear pair postulate. So this states that if two angles form a linear pair, then they are supplementary. So again, you don't need to memorize the number, just memorize the name or what it says. So here, it states that 1 and 2 form a linear pair, so then 1 and 2 are supplementary, and then you could also state that angle 1 plus angle 2 equal 180 degrees. Now, when you're writing proofs, keep in mind we have the linear pair definition, a linear pair postulate. So when you're writing a definition or a postulate or a theorem as a reason, you need to specify which one you're talking about, because you're going to lose points if your reason was supposed to be the linear pair postulate, but really the real answer was definition. You would get points taken off if you tell me it's a postulate when it should be a definition. So know the difference. And the next two slides are talking about vertical angles. The first one that you're going to see after this slide is the definition, and then the slide after that is the theorem. You need to know the difference. Now, we already learned prior to this lesson the definition for a vertical angle. And a vertical angle are two angles such that the sides of one angle are opposite raised to the sides of the other angle. So the definition tells you how the vertical angles are formed. Okay, so this tells you how they're formed. The theorem on the next slide is going to tell you that their angles are congruent. So know the difference. You will use the vertical angles theorem more than the definition in your proofs. Just realize that this definition is a valid reason if you need it in your proof. Okay, next we're going to talk about the vertical angles congruence theorem. And this theorem states that vertical angles are congruent. So if you want to abbreviate vertical angles congruence theorem, you can call this the VAT. We're going to use this a lot. So when you write it as a reason in a proof, if you just want to put the 3 letters VAT, you can, or you can spell it out and write the word vertical angles. If you want to use the congruent symbol for the word congruence, you can do that also. But what this tells me is that when I have vertical angles, their measures of the angles are going to be the same. So this would tell me that angle 2 is congruent to angle 4 because they're vertical angles, and angle 1 would be congruent to angle 3. So vertical angles are always congruent. Next slide has an example of a paragraph proof. Again, you will not have to write a paragraph proof, but just be aware that paragraph proofs exist. You just take your information and you're going to write it in sentences and form a paragraph with them. So this is an example of a paragraph proof. We're actually going to take this theorem, the vertical angles congruence theorem, and we're going to write a 2-column proof for it on the next slide. So again, the statements have been provided. You need to come up with the reasons. So again, my first statement is going to be given. So when you're writing your own proof, don't leave out this given, okay? This will be points towards the question. So if each statement and each reason is worth a point, you just earn yourself 2 points by just putting in the obvious. Again, each question will be, weighted differently, but if that were the case, just don't leave it behind. All right, so then the next one says that 5 and 6 are a linear pair and 6 and 7 are a linear pair. And this tells me this is the definition of a linear pair. Now, when it talks about the linear pair being supplements, that is the linear pair postulate. So know the difference. And then lastly, we can use our congruent supplement theorem because both 5 and 7 are both supplementary to angle 6. And now we'll just do 2 examples using everything that we just learned today. Try example 6. So here it wants us to find the value of x. So if I take a look at my picture, I can see that in order to find x, I actually have a pair of vertical angles here. So what I'm going to do is I know that this angle here, TPS, is congruent to angle, let's see if I can get another color here, QPR. So I'm going to state that angle TPS is congruent to angle QPR. Now, you don't need to write this down. You could go right into your mathematical equation that you're going to solve, but I just want to demonstrate that these 2 angles are congruent, the red and the green, because they're vertical. And we just learned the vertical angles theorem that says that these 2 angles are congruent. So I'm going to set this up as 148 is equal to 3x plus 1. I'm now going to solve for x by subtracting 1. I get 147 equals 3x. I'm going to divide by 3. And x equals 49. So if you want to flip it around. And that's how you solve for x by using your vertical angles theorem. The last slide has 3 true-false questions. So we'll go ahead and try those.
Like the page before.
This one? No. No, if it ever says solve for x, all you're really doing is this. And applying that theorem. So the first one, it wants me to classify the statement as true or false. So the first one, if the measure of angle A plus the measure of angle B plus the measure of angle C equal 180, then angles A, B, and C are supplementary. True or false? And this answer will be
True.
false. Okay, because by definition, supplementary is only a pair of angles. So in order for angles to be supplementary, we can only have 2 of them. So this was a trick question. So it did equal 180, but we had 3 angles here. We can only have a pair of angles in order to classify them as supplementary. Next one, vertical angles have the same measure. So congruent means same measure, so this one is true. We use our vertical angles theorem. Now for the last question, in order to determine if this is true or false, we've got to solve for x and double check that they got the right answer. So notice they're telling us that 1 and 2 are vertical, so that tells me that 2x plus 8, I'm going to set it equal to 3x plus 4. I'm going to solve for x. So you want to get your variables on one side and your numbers on the other. So I'm going to subtract 2x from both sides. And then I'm going to subtract the 4. And now that leaves me with 4 equals x. I think they did some math wrong. They said it should be 14. So this answer is false. X doesn't equal, yes.
Miss Corey?
Yes.
For the question before, do you have to do the 2-column proof?
No, these are just true, false.
No, so only when it says justify your answer, that's when we have to do the 2-column thing?
Yeah, if they tell you to justify each step, then yes. Generally what they'll do is they're going to tell you write a 2-column proof. That's how the instructions will be. But again, yeah, if the question says to justify your answer, you could set it up as a 2-column proof. Or like for example, on this problem here, number 3, if it just said justify your answer, what you could do here is to the side, you could just say, instead of writing in a 2-column, that this was subtraction, this one was subtraction. So you could justify it by showing the subtraction property of equality and not have to necessarily write it as a 2-column proof if the instructions just say justify. Any other questions? Anybody need me to go back to anything?